Assalamualaikum warahmatullahi wabarakatuh and hi. We are from course Industrial Chemical Technology AS125 and today we are going to present about application of differentiation on topic maximum and minimum problem. But before we going into today's lesson, let me introduce the member of group 3. So my name is FAAKHIRAH binti MOHAMMAD NIZAR and my matrix number is 2022890934 and I'm from group RAS1252D.
Hi and Assalamualaikum. My name is NORLIYANA binti SULAIMAN. My matrix number is 2022824116 and I'm from RS1252E.
Hi, my name is ALIAH binti ZAKARIA and my matrix number is 2022841098 and I'm from RS1252E.
And my name is UMAIRAH ZAFIRAH binti HALIM. My matrix number is 2022836692 and I'm from RS1252E.
First, we will start the introduction to maximum and minimum. What are maximum and minimum? Maxima and minima in calculus are found by using the concept of derivative. As we know, the concept of the derivative gives us information regarding the gradient slope of the function. We locate the points where the gradient is 0 and these points are called turning points or stationary points. These are points associated with the largest or smallest values locally of the function. Why we use maximum and minimum? The process of finding maximum and minimum value is called optimizations. We can use things like maximize the profit in a company or minimize the cost, or find the least amount of material to make a particular object. These are very important in the world of industry.
Step to solve maximum and minimum problems. For the first step, after finding we shall find the first derivative. Step 2, let the derivative equal to 0. Step 3, find the second derivative to test it. If second derivative more than 0 is minimum value. If the second derivative below than 0 is maximum value. Extra step to find the maximum or minimum area. Step 4, substitute maximum and minimum value into the surface area.
Okay, so today we're going to do some of questions from maximum and minimum problems. Refer from homework 51, question number 4. The diagram shows a window in the shape of a rectangle with semicircle on the top. The perimeter of the window is 4 meters. Okay, for perimeter is a total sum of all the sides. Okay, so pi r is a represent of x. Pi x over 2 plus h and plus x. Okay, so 4 equals to pi x over 2 plus 2h plus x. Okay, so when to cut off this number 2, I have to times off 2. So we got here 4 times 2 is 8 equals to pi x plus 4h plus 2x. Okay, so we want h in terms of x. Okay, 4h equals to 8 minus 4 pi x minus 2x. H is equals to 8 2x over 4. Okay, for question 4p, it shows that the area of the window is given by A equals to 16x minus 4x power of 2 minus pi x power of 2 over 8. Okay, A is equals to 16x minus x power of 2 minus pi x over 8. Okay, so basically the question just want the exact equation here. Okay, semicircle. Area of semicircle is pi r2 over 2 and area of rectangle is h times x. Okay, area of the window is pi r2 over 2 plus h times x. Pi pi r2 over 2 as the question for E. We already have H, so just insert the equation, and it's minus 2x minus pi x over 4 times x. Okay, pi r2 over 2 plus 8x minus 2x power of 2 minus pi x power of 2 over 8. Okay, also R for semicircle is a radius. Radius is present as x over 2. It is the semicircle formula for radius. Okay, so just insert also R x over 2 plus x 2x power of 2 pi x power of 2 over 8. Oh, sorry. Actually, here and here is 4. Okay, so simplified it as here plus fx x minus 2x power 2 by x. Okay, the denominator here and here is different, so we have to make it same. So just pi x over 8. This one you just have to times 2 to get the denominator same as here. Okay. 8 times 2 equals to 16x. 2 plus 2 times 2 equals to 4x power of 2, and then pi 2 pi x power of 2 equals over 8. Okay, so here the denominator is same, so just conclude it all. Same equation. X plus 4x power of 2 minus 2 pi x power of 2 and over 8. Okay, so positive x minus 2, we got negative pi x power of 2 plus 16x minus 4x power of 2 over 8. So just negative x power of 2 plus 16x minus 4 pi x power of 2 over 8. Okay, for question 4c, determine the maximum area of the window. So this is an equation from B. We just have to simplify it as 8 minus 4x 8 pi x power of 2 over 8. Just simplify, we got 2x minus 1 over 2 x power of 2 minus 4 pi x power of 2 over 8. Okay, 2x minus 1 over 2, you just have to rewrite it again. Okay, so here is differentiate of equation. We got 2 minus x because just 2, okay, minus 4 1 over 4 pi x. So here we want to use the denominator for this one, so we have to times it times 4. We got 4 times 2, 8. 4x minus pi x. Okay, so here let dA over dx equals to 0. 8 4x minus pi x equals to 0. A equals to 4x plus pi x. A equals to x. Just factorize it, so we got here for pi x equals to 8 over 4 plus pi. Okay, so we just have to calculate x 8 4 plus pi equals to x is equal 1.12. So the maximum area of the window is 1.12.
So next we're going to look at question number 6. Question number 6 is about an open top aquarium with a volume of 36 meter cube is to have the length twice as long as its width. Let x and y be the aquarium's width and height respectively. So question A, we need to express y in terms of x, and B, show that the surface area of the box is given by A equals to 2x squared plus 108 over x. And C, find the minimum surface area of the box. Okay, so before we solve the question, we need to draw an open top box aquarium. We know the aquarium will be a cuboid shape, so it will be like this. So it will be like this, and we just label the width. This is the width, and this is the height, and this will be the length. And it's given that x will be the width, y is the height, and it says that length have twice as long as its width. So the width is x, so the length will be 2x. So to solve this question, express y in terms of x. We just gonna do the volume formula because it's give that volume is 36 meter cube. We just multiply the length, the width, and the height, and equals to 36. We will multiply this, we will get 2x squared y equals to 36. And then we will do step by step to avoid the careless mistake. So x squared y equals to 36 over 2, and we'll get 18. And then we will bring x squared to the other side, and we will get y equals to 18 over x squared. And this will be the final answer. So next, for question B, show that the surface area of the box is given by A equals to 2x squared plus 108 over x. First, we need to know the formula of surface area for an open top box is 2 length height plus 2 width height plus length width. This is the formula for the surface area for an open top box. And then we just need to substitute the value of length, height, and width into this formula. 2, we know that length is 2x, height is y, plus 2, width is x, and height is y, plus length is 2x, width is x. So we simplify this, we will get 4xy plus 2xy plus 2x squared. We simplify it again, we will get 6xy plus 2x squared. And from this, we already know the value of y, which is 18 over x squared. We get it from the question A. So we just need to substitute value of y into this. So we will get 6x 18 over x squared plus 2x squared. 6x multiplied by 18, we will get 108x over x squared plus 2x squared. We can simplify this by cancel out x and square. So it will be 108 over x plus 2x squared. So it's shown that this surface area is same with the given. So this will be the answer for B. Next, we're gonna look at question C. We need to find the minimum surface area of the box. We know the area of the box is 2x squared plus 108 over x. We can simplify this. 2x squared plus 108 x to the power of negative 1. Because first step, we need to find the first derivative. So it will be dA over dx equals to 4x minus 108x to the power of negative 2. Next, for the second step, we need to let dA, the first derivative, dA over dx equals to 0. So it will be like this. 4x minus 108x to the power of negative 2 equals to 0. From this, we need to find the value of x. So 4x equals to 108 over x squared. Because we will bring x to the power of negative 2 down. Okay. So 4x multiplied by x squared equals to 108. We get 4x to the power of 3 equals to 108. X squared, x to the power of 3 is 108 over 4. So 108 over 4, we will get 27. So x equals to square root 3, 27. We will get x equals to 3. So after find the x, value of x, we need to find the second derivative, which is for the step 3. Find second derivative. So d 2a over dx squared equals to 4 plus 1 negative 2 multiply negative 2 multiplied by negative 108. We get 216 plus 216 x negative 3. How we get this? We just find the second derivative from the first derivative from this one, and then from here we just gonna substitute the value of 3. So when x equals to 3, 4 plus 216 multiplied by 3 to the power of negative 3. So we just calculate this. 4 plus 216 to the power of negative 3. We will get 12. So we know that from the test value, from the second derivative test, we know that 12 is more than 0. So it proved that this is the minimum value. But the question asks to find the minimum surface area of the box. So to find the minimum surface area of the box is from area of the box 2x squared plus 108 over x. We just gonna substitute the value of x. So 2 plus 108 3. Calculate this and we will get 54 meter square. So this will be the final answer.
For the conclusion, we should identify the right formula. At accomplishing both first and second derivative correctly will lead to a solid answer, maximum or minimum value.